This tutorial is to provide you a review to help you prepare for the test, which will be over the chapter on loops. The chapter on loops is chapter 5 in your book. Okay, first thing I'd like to do is let's just step through the terms, just make sure we understand all the terms. A loop is a control structure that just repeats a group of statements in a program over and over. So that's pretty easy to remember. Iteration means to do something over and over. As we go through the loop over and over, it's kind of similar to the term loop. With each pass of the loop, we do a loop. With each pass of the loop, we can do an iteration. So the two words can be used interchangeably in that respect. A loop body, to see that, I'd like to go ahead and put together a program that uses a loop body. I'll call this 0, 1, and I want to make sure I make a Win32 console application, and let's go ahead and create it. Now, let's flesh out this program. So I'll say pound include IOStream using namespace std, and down here let's clean up our main. If you happen to be working in the bloodshed environment, of course you don't need pound include std-afx. It's just a quirk of Microsoft. Technically it probably shouldn't even be there. We need to put in a system pause if we want to see our results. Most of the time when you submit your assignments to me, I don't even want to have that line pound include std-afx, because most of you, I grade your assignments in TextPad. I don't even use Microsoft. So it's a little more cross-compatible if you don't have that line. Now, I'm going to make a for loop. Typically in a for loop, we say int I. I is usually the favorite variable. There's no particular reason for it, but that's the way it usually is. I'm going to display the numbers 1 through 5, and I'm going to say I++, which we know to mean I is equal to I plus 1. Now I'm going to go ahead and output those values to screen as I see them appear. So I'm going to see out I, and then after each value I'm going to put a space, then a semicolon, and then not to run the output into the line that says system pause, I'm just simply going to say cout indel after I complete creating that entire list of numbers. So if I rebuild this, here you have a very simple for loop that outputs the numbers 0, 1, 2, 3, 4. The point of being, in my notes, what I was just talking about here, let me move this off to the side, is we have iterated through this loop. We have looped through this loop. I'm bringing up a new term here, which is called the loop body or the loop block. What is that? That is everything inside the braces. So in this particular case, there's just one line inside the braces, and it's the cout statement here. So that would be the loop block. We also have something called a counter-controlled loop, and that occurs anytime you're counting. And as we've already described in this class, if you go up by a fixed amount, and certainly I++, since I is equal to I plus 1, is what it means. 1 is definitely a fixed amount. So this is a counter-controlled loop, and in this particular case, the counter we're using is I equals I plus 1. Okay, I have a little bit of redundancy here. I see I have loop body here again. Let me go ahead and strike that. I should have it explained up above. There's also something called loop control variable. Obviously, in this loop which I have here, the loop control variable is I itself. So that would be the loop control variable. It is the variable that has to meet the condition for you to exit. Next thing I have here is an infinite or a runaway loop. That's easy enough to make. If you have a situation which can never be met, for instance, if I say we're going to do this loop as long as 0 is less than 1, that's a statement that's always going to be true. So if I see how long I run this loop, I'm going to run this loop forever. So if I rebuild this and I start it off, I'm just going to get a bunch of numbers that increasingly get bigger, and at some particular point my values for I are going to become so large that my program will crash. I will not be allowed to have an integer that large. Until then, I would call this a runaway loop because I have no control over it anymore. It's also called an infinite loop, and actually I prefer the term infinite loop. To stop a loop like this, all you have to do is just close the window top right is probably the easiest way. So if you're working at Microsoft, that's the easiest way. There are other mechanisms you can use. You can usually hit Control-Alt-Break. A lot of times that'll stop the loop too. I really didn't want that to happen, so let's just say I is less than 10. So anyway, you now see firsthand what an infinite or runaway loop is. Now, sometimes when we do a loop, we go up by 1. And I was just doing that in the loop that I had here for a for loop. Wherever you go up by 1, this is called an incrementer. I can give an example of an incrementer in a while loop. I can say while x is less than 5. Now, if I'm doing a while loop, I do have to declare the variable. I do have to initialize it. I'll initialize it to a value of 0. So here I initialize. Here I test. I'm now going to put in some braces. The braces are not necessary if you just have one line of code that you need to execute. I'm going to say x is equal to x plus 1. Again, this is an incrementer. And if I run this, we should see some output actually that we should be able to predict. If I just bother to output it, let me say cout x, and then I'll put a space after that, semicolon, and we should see now a group of numbers that first outputs is 0. We're going to go up to those numbers which are less than 5, the last one being a 4, so we're going to see the numbers 0 through 4, and then we're going to exit the loop. Well, again, this is an incrementer, just like what we had before in our for loop. By the way, this particular line is called the update. So here I initialize, here I test, here I update. Those are the 3 parts of a loop. Those 3 parts are built right into a for loop. Here is my initialization statement. Here is my test. Here is my update. So a for loop has those things too. On the quiz, you need to know how to set this up. It's very important you know how to set up a for loop. By the way, we have seen examples in this chapter where we may have multiple initialization statements, multiple tests, and multiple update expressions. So all of that is also possible. So let's go ahead and run this program so that we can see both loops. Both of these are incrementers, 2 different loops doing basically the same thing. So when you go up by 1, as I've said here, this is called an incrementer. That now gets me to a counter. If I change things just a little bit, I'll go with the same variables that I was using before, and again I'll use a while loop. I can't redeclare x. I can only declare x once. So now I'll just say let's reset x equal to 0. So here I've initialized, I've got a test. I'm going to update. Here, just for a change, I'm going to go up by some value other than 1. Now, when you go up by some fixed amount, in this case the fixed amount is 3, this is called a counter. Turns out, since you're adding 1 each time in x equals x plus 1, this 2 is a counter. Obviously, adding up 1 each time to whatever you had before, that 2 is a counter. So all incrementers are counters, but it is not necessarily true that all counters are incrementers. In fact, x equals x plus 3 is definitely not an incrementer because it's not going up just by 1. So if I change this condition a little bit, here we start at the value of 0, we're going up by 3, so I would predict the output of this loop is going to go 0, 3, 6, 9. We never see the 10, so that should be where we exit the loop. Let's go ahead and see if that's so. And there we go. It is exactly what I predicted. Now, one thing you want to be aware of with loops like this is that we do have a while loop. There is also a do-while loop. So I'll copy what I have here, and I'd like to give an example of a do-while loop. The way a do-while loop starts is it starts off with the word do, and where you had the while and then the condition, if you just cut that just as you have it, not change a thing, and just move it down beyond the closing brace and then put on a semicolon, we now have a do-while loop. And about the only difference between these two loops is on a while loop, your test condition is at the very beginning, so you may not even do one pass of the loop. On a do-while loop, there is no condition at the beginning of the loop, so you are going to do at least one pass of the loop. This will come up on the quiz, so make sure you understand the difference here. Other than that, the output is going to look identical. Now, one thing I didn't do here was when I pasted this down, I see that I never initialized the second loop. So if I want to see similar output, I better make sure I initialize the loop. Let's go ahead and rebuild this. I should see the same output twice. And there we go, 0 through 9, 0 through 9. In this particular case, there was really no difference in the output I was going to see from the loop. Okay, and again, this is an example of a counter. A for loop also can be used with a counter. You can say I is equal to I plus 3 if I want to. That would work. This would be an example of putting a counter within a for loop. But I really don't want to do that. Let's just leave this the way we had it written before. One thing that comes up quite a bit when you're talking about loops is shorthand. Here in this last loop I said x equals x plus 3. Turns out there's another way I can write that. I can say x plus equals 3. This means x is equal to x plus 3. I, in a way, don't like this because if you're a person that doesn't know C++, you look at this line of code, it probably doesn't mean too terribly much to you, x plus equals 3. So it actually makes the code a little bit confusing, but there are a few shortcuts like this we do in C++ that professional programmers like, and this is a very common convention. So I'm going to expect you to know it. So if I say plus equals 3, that equals x plus 3. Turns out you can do it with all of the symbols in addition to plus. If I write x minus equals 7, what have I just written? Sure, that is the same thing as x equals x minus 7. What happens if I write x times equals 4? What is that equal to? X is equal to x times 4. What if I say x divided by equals 2? Why, that's the same thing as x is equal to x divided by 2. It would even be possible to use the modulus when you're doing this, but you almost never see that. So these are the common ones that you see. Some other shorthands you see sometimes is you'll see x minus minus written for x is equal to x minus 1. You may see it on the other side. It is appropriate to write minus minus x. And that too also means x equals x minus 1. The same can be done with an incrementer. I just showed two ways of doing a decrementer. Here is an incrementer. X is equal to x plus 1. That's one way I can write it. I can also write it x plus equals 1. That's another way I can write it. I can also write it minus minus x or plus plus x. I can also write it x plus plus. So you can see there's 4 different ways of writing the counter or the incrementer that I've got here. So you just need to be aware of this. Now, the next thing I've got in my list is I've got decrementer. We've talked about that. That's where we go down by 1. I now have a running total. I think what I'm going to do is I'll go ahead and end this tutorial and we'll pick up running total in the next tutorial.